Okay, so I'm not going to do this whole problem, but I'm going to at least help you set up with the picture. Now, I added a couple of lines in black just to kind of highlight this angle of inclination of the hill. It's the same as an angle of elevation. So it's formed from, like, here's the horizontal, and we have this 58-degree angle. Then you have this angle alpha that they gave you, that this is this smaller angle. And we also know a particular distance. Let me make this a little smaller. We know that this distance here is 100 meters. So my triangle that I'm actually using is like that would connect there, even though I don't need to know that side. And then this is what I'm trying to find, what's in red, the length of the wire. So I'm just going to call that, I'm just going to call it D for the distance. So I want to find that. So think about I'm trying to set up for the law of sines. Now, when they give you this angle down here, this 58 degrees, I'm going to add in another line across here. Make sure this is still. If I were to draw in parallel to this part down here, this little portion right here, this angle is also 58 degrees because they're corresponding angles. So this 58 degrees and then this 58 degrees right here. So I know that this is 58 degrees, and I also know alpha, the angle alpha is 12 degrees. So did I even need the 58 degrees? Not sure that I needed that right there or not. Okay, so going on with that, you'll see I added in another parallel line. So I have these from my hillside thing. I also had this parallel line, but I also added one more. And the reason for that is remember that when you have parallel lines cut by a transversal, then we're already making use of the fact that the corresponding angles are congruent. But there's something else too that says that alternate interior angles are congruent. So this is congruent to this. So remember all that stuff that Miss Yoder taught you in geometry? It's important because here we are needing that because trigonometry is using geometry. So if you look at our figure, then that means that this 58-degree angle, or I could use this one up here, is also congruent to this portion right here because those would be alternate interior angles. So this is 58 degrees. And this right here, even though it's not looking extremely vertical, but it is because it's standing, it's a vertical tower on the hillside. So this little portion is 90 degrees. So if you take 90 plus 58, you get 148 degrees. That's this whole angle right here. Notice that that angle is opposite side D. So now I know this little angle right here, which is 12 degrees. And actually that means I can figure out this angle up here because the three angles have to add up to 180. So if you take 148 plus 12, you get 160, and 180 minus 160 is 20. So this one up here is 20 degrees. And now you have the pieces you need from this triangle. So we have sine of 20 over the opposite side would be the 100 that they gave us. And sine of this angle we found here, sine 148. And the opposite side, the guy wire, which is what we're trying to find, is D. So I guess I pretty much did do the whole thing for you. Not easy, but notice this is not the first time we used, well, maybe for alternate interior angles, but this idea of parallel lines cut by a transversal, using alternate interior angles and using corresponding angles, that those are congruent. We come back to that again and again on these problems. It won't be the last time either because once we do something called law of cosines, we're going to have word problems for the law of cosines as well. This is going to be kind of a similar setup. So this time we are actually trying to find, I drew in, we're trying to find the angle of inclination of the hill. So this is actually what we're trying to find. So we've been given some information, and we know that this angle right here with this this vertical dash line here they have, and the hillside, we know that's 8 degrees. We know the height of the tower is 30 meters, and we know this is 120 meters. Now this is the side that's opposite this angle. So I'm just going to call this angle X, and we're going to have to solve for that using the law of sines. So if I do sine X over the opposite side is 120 equals sine 8 over 30. So that's what we're going to solve on that. So if we take 120 sine 8 divided by 30, I get sine x is about 0.5567, but I want x, not sine x, so I have to do inverse sine of my previous answer, and I get x is about 33.8 degrees. So that's this part right here. Well, now if I know that and I know that, now I can find this angle right here. So if I take 33.8 plus 8, and I want to do 180 minus that, so I get that this angle here is about 138.2 degrees. Now, keep in mind that from that, and I'm still going to have to make use of, change the color on here, this idea of, I'm going to make a parallel to this base down here, because if, get back to the pin, now I know that this is also theta, right? Because here I have parallel lines cut by a transversal. So if this is theta, this is also theta. So if I take my whole answer I just got, which was 138.2, and this little piece here is perpendicular, so subtract 90, and I get that theta is about 48.2 degrees, and that is my angle of inclination of the hillside. Okay, so I will admit those are not easy problems, but I also want to point out to you that when parallel lines are cut by a transversal, that idea of alternate interior angles and corresponding angles being congruent is really important when you are doing these word problems. So you're going to, again, remember that.